My name is Talia Cohen, and today I'm going to be explaining the lovely world of science, but more specifically, acids and bases. So we'll first start off with acids. They have three definitions: Arrhenius, Bronsted-Lowry, and Lewis. Arrhenius says that acids produce H positive or H2O positive. Bronsted-Lowry says that acids donate the H positive proton. Lewis says that acids are electron pair acceptors, and we can really tell whether something is an acid or a base using litmus paper. So I have some vinegar. Yep, that's definitely vinegar. We will take this blue litmus paper, dip it in the vinegar, and it should turn red. So let's find out. Would you look at that? It turned red. So we know vinegar is an acid. Many are familiar with the pH scale, but not many are familiar with the pOH scale. So I have this lovely chart here. And as you can see, you have your acids, your bases, and your neutral. On the pH scale, acids are below 7, but on the pOH scale, they're above 7. Now, to explain the pH scale a little bit further, we know that 0 is the most acidic, 14 is the most basic, and 7 is neutral. Now when we think about it, 0 to 14 isn't that large. But if you really delve into the science of it, it's actually to the power of 10. So 1 to 5 is 100,000, 1 to 6, each time you would be adding a 0. So it actually is a really big amount. And once you get to pH 14, it's 1 and 14 zeros. Now, how do we calculate pH? pH is calculated using logarithmics. So to calculate the pH, it'd be negative log, and then brackets H3O positive, because you're calculating how much H3O positive there is, or how much H positive there is. So we just talked about acids, and now it's time for bases. So bases also have three definitions because you can't just leave them out. So we have our classic Arrhenius, which explains that bases produce OH negative. We have Bronsted-Lowry, which explains that bases receive the H positive proton from acids. And we have Lewis, which explains that the bases are the electron pair donors to the acid receivers. Now, what's special about bases is that it turns litmus paper from red to blue. So I have some baking soda, my red litmus paper, and I mix this baking soda with a little water so the litmus paper can read it. And we should get blue. Would you look at that? You get a pretty nice color blue. Now, bases, we go back to our chart. Bases on the pH scale are above 7, and on the pOH scale are below 7. So when we use bases, we usually use the pOH scale because that measures the amount of OH negative that's in a solution. And our pOH calculation isn't too complicated. It's like our acids, except this time we aren't looking for H positive or H2O positive. We're looking for our OH negative. So it should be negative log brackets OH negative. Now the logs measure the concentration or molarity, and to go from pH to pOH is quite simple. So they should add up to 14. So if you have a pH of 7, your pOH would be 7. If you have a pH of 9, your pOH should be 5, and vice versa. So it's pretty simple when you're calculating it. So don't get too stressed if you do have to calculate it. Okay, so we have a few more basic, get it, things before we move on to the fun stuff in this video. So we're going to be talking about good old conjugate acid base pairs. So conjugate acid base pairs are formed when the proton H positive is removed or returned. So as you can see, you can go from HF, the conjugate base F negative, by removing the H positive. Or you can go from HSO4 negative, return the H positive, and now you have HF. So as you can see, I have multiple examples. And so HCO3 negative, remove the H positive, you have CO3 2 negative. NH4 positive, remove the H positive, you have NH3. And they go back and forth, and that's how you get conjugate acid base pairs. And they only differ by the presence of the proton H positive. To put conjugate acid base pairs into perspective, I've used an equation I've found off of Google. You see, we have CN negative and H2O, good old water, to HCN and OH negative. So as you can see, the H2O loses in H positive and forms OH negative. This is our conjugate base. Our base gains in H positive, which forms our conjugate acid. So as you can see, the base forms a conjugate acid, the acid forms a conjugate base. Pretty interesting. We're going to move on to talking about titration, which is sort of the same thing as neutralizing. So if you take something really acidic and you take something that's really basic and you put it together, you're trying to reach pH 7, that's when you're trying to reach titration. So that can be calculated by using MAVA equals MBVB. Okay, so now we're going to mix a few things together to see what their pH is, since litmus paper only measures if something is an acid or base, not how acidic or how basic it is. So I made myself some good indicator, cabbage juice. So I just took some cabbage leaves, mixed it with some water. My kitchen smells great. And so since we're using cabbage juice and it has a purplish hue, our pH color is going to look a little different. So on the most acidic end, we're going to have red, pink, and then as we approach neutral, we're going to have purple, and then when we approach basic, we're going to have blue, green, and clear. So I'm going to take water, yes, this is the water, and I'm going to add a little bit of cabbage juice, and we get this nice purplish hue. Little blue. So we're going to add a little bit more indicator. Oops, spilling cabbage juice on myself. We get this like nice blue. So that'll be our neutral. Next, we're going to move into something a little bit more basic. Baking soda with a little bit of water. Take our cabbage juice. We get this greenish hue. Blue, greenish. More of a green. Mix it around with our fingers. I wouldn't recommend doing it, but for science. Get this like blue-green hue. You can see compared to our neutral. It's a big difference. Next, we're going to go to our most basic that I have, which is soapy water. Take some cabbage juice, mix it together. We get this purple, which is interesting. So maybe the type of soap that I have. This is actually not really that basic, but as you can see, it's more acidic. It's pretty interesting. Next, we're gonna go pretty acidic. Some vinegar. Take our cabbage juice, should give us more of a pink. Would you look at that? Now we may have added too much of the cabbage juice to the soapy water, which is why we didn't get a nice green. If you use bleach in the cabbage juice, you'll get it clear. But this pink, as you can see, acidic, vinegar, pretty acidic. Let's compare that to our water. It's a big difference. Next, we'll go to the most acidic I have with me, and lemon juice. It's a pH of 2 or 3. Our vinegar also had a pH of 2 to 3, so it should be pretty similar. And we get this nice pink. Compare it to our water. Now let's see if we can reach titration, like a purple. So we'll take my most basic, which is baking soda. And our baking soda is pH of 8. So it's not too basic. We'll just add a little bit. Wow. So look at that, we get a nice reaction. Mix it around a bit. We still have blue. So as you can see, it's much more, baking soda is much more basic than the vinegar, but we should get, I mean, the vinegar is pretty acidic. Should be more acidic. Get some nice bubbles again. Mix it around. We should be getting close to green. Yeah, some nice aquamarine green. And we've pretty much reached titration. We've reached a neutral. Let's just dump in the rest for funsies. Wow, would you look at that? It's pretty amazing. Get awesome green. It's pretty neutral if you ask me. So now we're just gonna add everything together for fun, just to show you guys. Not much of a reaction. Ooh, wow. Pretty strong reaction. Be careful when you mix acid and bases, because sometimes it can produce really strong reactions. You can see some carbonation. We'll mix our soapy water. Take a blue. And not much of a reaction. As you can see, everything together. Everything together seems pretty basic. So you can see it's a green. But that's all I have for you guys. So have fun. Try not to blow anything up. If you do, at least record it. And have fun.